In this video, we're going to take a look at mole-to-mole stoichiometry. In one of the previous videos that we've done, we said that stoichiometry is basically a fancy way for working with chemical recipes. It's just ratios, molar ratios of reactants to products. This is very useful to chemists, chemical engineers, because like we said, it's a recipe that tells them exactly the quantities of reactants they need in order to make desired products. And this is beneficial in industry because if you're a company looking to make a profit, you don't want to waste material, you don't want to buy more things than you need to make your product. So this definitely has some real world applications. But whenever we hear mole to mole, we should probably smile to ourselves, if you will. We'll do a big smile because we know these are the easiest types of stoichiometry problems to do because there's no conversion to grams. We don't have to worry about molar mass. Mole-to-mole stoichiometry should make us happy or happier because these are the easiest types of them to do. So let's go ahead and look at one problem. So to make some room, so here's our balanced equation. So we've got 4 moles of aluminum mixed with 3 moles of O2, which is oxygen gas, will yield 2 moles of aluminum oxide. So our ratio here is a 4 to 3 to 2. So here it says how many moles of Al are needed to make 3.7 moles of aluminum oxide. Well, just as in the examples for the cake stoichiometry, if you will, we don't know how many moles there are, so we're going to say X moles of aluminum. So I'm going to put that on the left-hand side of my ratio. The other thing that they tell us is 3.7 moles of aluminum oxide. So I'm going to say 3.7 moles of Al2O3. Now remember, mol, mol is the abbreviation for mole. It's not much of an abbreviation because you're just taking one letter off, but anyhow, mol is the abbreviation for moles. So here I've got moles of aluminum on the top. Moles of aluminum need to stay on top on the right hand side. Now once again, it doesn't matter. On the left here, I could have put moles of aluminum on the bottom and moles of aluminum oxide on top. It doesn't matter. What matters is whatever you do choose to put on top must stay on top here. So with that reasoning, let's go ahead and put moles of Al2O3 on the bottom here. The right-hand side of the proportion comes from the recipe. Now the recipe is our balanced equation. So these are the numbers that we are going to be interested in, the 4, the 3, the 2. So I've got moles of aluminum on top, and I've got moles of aluminum oxide on the bottom. So if I look at my balanced equation, I know that there is a 4 to 2 ratio. For every 4 moles of aluminum, I can make 2 moles of aluminum oxide. So I'm going to go ahead and indicate that on the right hand side. 4 moles of aluminum will make 2 moles of aluminum oxide. So once here we've got our proportions set up, and from here on out it's basically just doing calculations. So 3.7 times 4, let's see here. So we've got 3.7 times 4 is going to give us 14.8. So we're going to say 14.8. So I'm just multiplying these two. Then I'm going to take 2 times x is equal to 2x. So now once I get here, I just want to get x by itself, so I'll divide this side by 2, divide this side by 2. So now I'm going to come up with x is equal to 7.4 moles. Okay, so moles of what? So if I look back into the way I've set it up with the x, I had moles of aluminum, so that's going to be my answer here. So moles of aluminum. Remember, the units on your number are just as important as the number itself. So let's scroll down and do one more type of problem. Or not type, but just another problem. So in this one it says how many moles of aluminum oxide can be made from 0.78 moles of O2. So once again, we don't know how many moles of Al2O3, so let's say X moles of Al2O3. And we're going to put that over the other thing that they have in the problem, which is the 0.78 moles of O2. Alright. Now the right-hand side comes from our balanced equation, but I'm going to keep my units consistent. So I've got moles of Al2, O3 on top, and then I've got moles of O2 on the bottom. So if we scroll back up to the balanced equation, we want aluminum oxide to oxygen. Aluminum oxide, there are 2 moles of aluminum oxide to 3 moles of oxygen. So it's a 2 to 3 ratio. So we have 2 moles of aluminum oxide to 3 moles of oxygen. So now we've set up the proportion. The next thing that we have to do is cross multiply. 0.78 times 2 is going to give me 1.56. And when I take 3 times x, that is going to give me 3x. And at this point, I'm going to divide this side by 3, divide this side by 3. So my x is going to be equal to 0.52. And the units on that, the units for my x was moles of aluminum oxide. So I'm going to say moles of Al2O3.